So question 4 says, determine whether the graph on the right is that of a function by using the vertical line test. If it is, use the graph to find the following. So we want to find domain and range. Assume that the curve approaches but never intersects the y-axis. Okay, so they're saying it does not touch the y-axis, so that's going to be a boundary line. So if you look at the graph over here, this y-axis is not going to actually cross the y-axis. So that's what they're making as an assumption there. So try to find any intercepts and then symmetry, since there's asymmetry. So the first thing is, does the graph represent a function? So notice that it does pass the vertical line test. It doesn't matter where I draw a vertical line through here. It is going to touch the graph in only one spot. So yes, this is a function. So yes, the graph is a function because every vertical line intersects the graph at most one point. That sounds pretty good. That's what this other yes is. Yes, the graph is a function because the vertical line intersects the graph in more than one point. No, that's not what it does. It has to touch just one point. So that would be our best choice there. So what are the domain and range of the function? So remember, domain, you have this left bound, right bound. So notice how this arrow is a left bound, but notice how it's not going to cross the y-axis. So remember, x equals 0 is the y-axis. So notice how it actually is not going to go, it's actually not going to touch the y-axis, so it's got to be to the right of 0. And notice how there's this 4 over here as well. So it can't be 4 either, so it's got to be between 0 and 4. So using interval notation, we can't include 0, and we're going up to 4, but we cannot include 4 either because of that open circle. Open circle means do not include the endpoint. So the range is lower bound to upper bound. Now notice this graph does point downward, so there is no lower bound. That means we're going to use negative infinity for that. But the upper bound, notice that the highest y value that we're going to see is it's not going to go past the point 4. So 4 becomes my upper bound. So using interval notation, the range goes all the way down to negative infinity, so there's no boundary going down, but there is a boundary going up, which is at 4. So the graph does not go past this point here, but again, it goes towards negative infinity. So that would be my range. So the next question is, what are the intercepts? So select the correct answer from there. So notice how it wants us to type these as ordered pairs. So if I'm looking at the x-intercept, looks like 1 is where it crosses. So as an ordered pair, we want to write that as 1, 0. That's going to be the x-intercept. But notice to be a y-intercept, it's actually got to touch the y-axis. And notice how they said up here that the graph is only going to get close to the, so if I look back up here a little bit, the graph only approaches but never intersects the y-axis. So if it doesn't touch the y-axis, there's not a y-intercept. So there's only going to be an x-intercept, which is going to look like 1, 0. So as far as symmetry goes, for y-axis symmetry, the graph has to mirror itself across the y-axis. So if there's this point 4, 4, there's got to be another point over here, negative 4, 4. I don't see it. So there's not y-axis symmetry. For x-axis symmetry, if there's a point at 4, 4, there's got to be a point reflected over the x-axis, which would have to be at negative 4, 4. And I don't see a point down here at negative 4, 4 either. So the graph does not look like it's mirrored across the x-axis. For the origin, there's got to be this mirroring across the origin. So if there's this 4, 4, there's got to also exist this negative 4, 4. So we're not seeing kind of mirroring across the origin either. So this does not have any symmetry. So from what we're talking about, there's no x-axis, y-axis, or origin symmetry. Now, it was a function, but it didn't have any of these symmetries, so we just had no symmetry there.